Hey everyone, today we're going to start Unit 3, which is all about trigonometric functions. We're going to start with basic, just talking about angle measurements. The first thing is an angle on the coordinate plane is in standard form when the vertex is on the origin, so like in this picture, and one ray lies on the positive x-axis. That ray that's on the x-axis, we call that the initial side, since that's where we would say our angle begins. And then the other ray, the one that's not on the x-axis, we call the terminal side. Okay, so now that we have our angle in standard form, when we measure it, we can measure it in two different directions. So in this picture above, the arrow goes up and then to the left. We call that counterclockwise rotations. So when you go up first, and that will result in a positive angle measurement. If it were to go the other direction, if it were to go down first, then around, that's clockwise, which would result in negative angle measures. So most of the time when we think of angles, we measure them in degrees. So if I were to start there at the positive x-axis and make one full rotation, a complete circle, that is equal to 360 degrees. So now if I were to split this into 4 pieces, so I just want a fourth of a rotation, so just up to the y-axis, 360 divided by 4 would be 90 degrees. If I were to do half a rotation, that's a 180. And then 3/4 is 270. So we're going to practice drawing or just sketching some angles here. They don't have to be perfect, we're just estimating. So the first one that they give us is 65 degrees. So I know my initial side has to be on the x-axis, so I'm drawing that first. And then according to my measurements up here, a quarter of a rotation is 90. So up here would be 90 degrees. If I want 65, it has to be a little bit less, a little bit more than halfway. So I'm going to estimate that it's right here. So this angle, remember we're going up, that angle right there is what I am saying is equivalent to 65 degrees. Okay, our next one, 320, initial side on the positive x-axis. And if we follow our pattern, this would be 90, 180, 270, and then going all the way around is 360. So 320 has to be somewhere in this quadrant. It's in between 270 and 360. So I'm going to estimate it to be about right there. And remember, we're going counterclockwise, so up and around. That's the angle. Okay, the next one is negative 110. So initial side. But this time, since we have a negative angle, we're going to go clockwise, which means that we need to go down first. So this would be negative 90, negative 180, negative 270. And we are measuring out negative 110. So here's 90, and then there's 180. It has to be somewhere in between. So let's say about right here. So our angle's going down first. Okay, and then the last one we have is negative 205. Initial side, we're going the negative direction, so this would be negative 90, negative 180, negative 270. Okay, so I'm going to stop there. 205 has to be somewhere in between these two. Something like that. So this part is my angle. Okay, so degrees, since that's commonly used in the real world, tends to be the easier one to picture in your head. But degrees are not the only way to measure angles. Degrees were just made up arbitrarily by somebody. The more accurate measurement of angles is called a radian. A radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So over here I have a circle. So what they're saying is that a radian would be when the intercepted arc, so this part right here, is equal to the same length as the radius. Like those two pieces would be the same length. then that means that whatever is inside, so that theta right there, would be equal to 1 radian. So an easier way to remember this is recall that the circumference of a circle, the formula to find that is 2 pi r. So r is the radius. But in this case, because I want the radius to be the same length as the arc, I'm just going to ignore that r part. If I want to do a 360, meaning I want to go all the way around, it would just be 2 pi. So 2 pi radians. And then halfway, that 180 would just be pi radians. Okay, so we're going to talk about how to switch in between degrees and radians. The conversion factors are right there. If you already have radians and you want to convert it, you get your degrees and times it by pi over 180. And if you have degrees and you want to change it to radians, you multiply by 180 over pi. It's the same conversion factor, just flipped. Okay, so on the back, we have a few examples that we're going to go through. So convert each angle measure to radians. That's when we need to multiply by pi over 180. Okay, so 60 degrees. We're going to multiply by that conversion factor, 180 over, or pi over 180. I want the pi to still be there, so you can't just type this into your calculator. You have to simplify it by hand. So think of this as 60 over 180 pi. How would you simplify this? Well, they both have zeros, so I would cancel that part, and it would just be 6 over 18. But then I know I can divide both of those things by 6. It would be 1 over 3. So really, I would change this into pi over 3. Okay, the next one, negative 75 degrees. It's just the same thing over and over. So negative 75 times pi over 180. And then simplify this as much as you can. I know that both of these are divisible by 5s. That would be 15 over 36. But then those numbers are divisible by 3. So that would be 5 over 12. So yeah, the final answer here would be negative 5 pi over 12. The next one, 330 degrees. Multiply that by pi over 180. Okay, the zeros cancel out, so that's 33 over 18. Those are both divisible by 3, so that is 11 over 6. And I think that's as simple as it gets. So this could be 11 pi over 6. Okay, and then the last one, negative 45 degrees times pi over 180. Both are divisible by 5, so that would be negative 9 over 36. But then both of those can be divisible by 9, so 1 over 4. So you don't really need to write the 1. It'll just be negative pi over 4. Okay, now let's do the opposite direction. If they already give us radians and we want to convert it to degrees. So this time we're going to multiply by 180 over pi. 5 pi over 18 times 180 over pi. So a few things you should notice right away is that the pi symbol is going to cancel out. 180 divided by 18, that's just 10. So I have 5 times 10, which is 50. So this would be 50 degrees. Seven pi over 3 times 180 over pi. Pi symbol is going to cancel out. I know that 180 divided by 3 is just 60, so I have 7 times 60. So that would be 420 degrees. Negative pi over 6 times 180 over pi equals, the pi symbols are going to cancel out. And then 180 divided by 6 gives us 30. So this will be negative 30 degrees. And then last one, negative 19 pi over 12. Let's multiply by 180 over pi. Pi symbols are going to cancel out. This one's a little bit tougher. 180 divided by 12, that actually gives us 15. And then negative 19 times 15 would give us, let me check. I think that's 285. Yeah, 285 degrees negative. Okay, so that is something that we need to get super good at, converting between radians and degrees, because depending on the problem that they give us later on, it has to be one or the other. Okay, last new thing that we're going to talk about are coterminal angles. And I believe that this is exactly what it sounds like. So if terminal means where they end, and we want angles that are coterminal, that means that we need angles in standard position that have the same terminal side. They're going to end in the same spot. So I'm going to draw a little picture here. Say we had an angle like this. But then if we have another angle that starts the same, goes all the way around, and then around again, but then it stops in that same spot, those two angles would be coterminal. So because you have to make a full rotation, the measure of those coterminal angles are always going to be different by some multiple of a full rotation. So that means in degrees, that would be 360, or in radians, that's 2 pi radians. So these examples right here, they just want a yes or a no answer. Are these angles coterminal? Would they end on the same spot if I were to graph them? Okay, so it even says the word differ, and difference means subtract. So that's what we're going to do here. Let's get negative 305 and subtract 55. And when you do that, you should get negative 360 degrees. So since that is a full rotation right there, I know it's negative, but it's still a rotation. That means that, yes, those two angles are coterminal. Okay, let's do this one. 30 degrees and negative 170 degrees. So let's go ahead and subtract them. So minus a negative number is going to turn into adding. So this is basically 200 degrees. That's not a full rotation. So these would land in two different spots. So these are not coterminal. Okay, then I have the two angles pi over 4 and negative 9 pi over 4. So in this one, we're going to have to subtract fractions. So you just have to make sure that they have the same denominator, which they do. They both have 4 at the bottom. So let's just subtract them like normal. Pi over 4 minus negative 9 pi over 4. That double negative here is going to turn to a plus. And one thing to remember is that this pi has an invisible 1 in front of it. So 1 plus 9 would give me 10. 10 pi over 4. And then let's just reduce this as much as we can. That would be 5 pi over 2. So what we want to know is that a multiple of 2 pi? Well, because 2 pi is a full rotation. I could have 2 pi, 4 pi, 6 pi. It's never a fraction. So if you ever have a fraction, that is not a full rotation. So this is not coterminal. Okay, and then one more for practice. 3 pi over 2 and 11 pi over 2. Okay, they already have the same denominator, so we're just going to subtract across. 3 minus 11 gives me negative 8. So that would be negative 8 over 2, which if I simplify that, it's just negative 4 pi. 8 divided by 2 is 4. So this here, I know it's not 2 pi like a rotation, but if you were to do 2 rotations, it would come out to 4 pi. So these are coterminal. Yes, coterminal. I'm just going to write here on the side. That would be 2 full rotations. Okay, and then the last 2 problems just want us to come up with our own coterminal angles, and we want one that's positive and one that's negative. So if they already give me 265 degrees, I want another angle that's going to land in that same spot. Let's just start by, well, let's add 360. Let's do a full rotation from there. So 265 plus 360 gives me 625. So 625 would be a coterminal angle. So that's the positive one. They said that they also want a negative. So let's try subtracting 360. 265 minus 360 gives me negative 95. So all 3 of those angles, the original plus these 2, all of them would just all look like the same angle. Okay, and then last one, we're going to do this one in radians. So we're going to add a full rotation. We want to add 2 pi. The issue here is that when you're adding fractions, you need to have the same denominator. And remember, 2 pi has an invisible 1. So in order for that to become the same denominator, I'm going to rewrite that 7 pi over 6. I'm going to rewrite 2 pi over 1 as 12 pi over 6. Because 12 over 6 gives me the 2 that I need anyway, and now they have the same denominator. Now I could add across. 7 plus 12 is 19. So 19 pi over 6 would be one of the coterminal angles. And then now let's subtract. And since I already know that I need to write it as 12 pi over 6 to have a common denominator, 7 minus 12 would give me negative 5. So negative 5 pi over 6 would be our negative coterminal angle. Okay, so these notes, I know it seems like a lot. It was a lot of vocabulary that we need to know. Make sure that these get written down, and then you should have an assignment to pick up and do today. Let me know if you have any questions.